Okay, continuing on with 13.8b, let's use what we know about reciprocal functions to graph y equals cosecant of theta minus 1, but this time we're going to do it without a table. So I know that cosecant is the reciprocal function of sine. So I'm going to rewrite this as y equals sine of theta minus 1 to start with. And really what I'm going to do is first I'm going to graph the reciprocal function. Y equals sine theta. I'm going to ignore the minus 1 for now. Next, I'm going to use that to graph, sorry guys, graph the y equals cosecant of theta. And just like we did with translations, I'm saving the translation for last. Translate, since this minus 1 is outside of the parentheses, it's not parenthesis theta minus 1, I'm going to translate this down 1. Everything goes down 1. All right. So I'm going to start by labeling my values. All right. So we're going to graph y equals sine of theta. So sine starts at 0. If I'm just graphing this, there was just a 1 here and a 1 here. That means that my amplitude is 1 and my period is 2 pi. Nothing changed there. If there had been values here, that's not absolute value, that's a 1. I just realized that looked like absolute value. If there had been something like a 2 here, I would bring that down to this part right here. So I'm going to have y equals sine of theta, so period of 2 pi. So it starts at 0 and ends at 2 pi. Halfway point is pi. My maximum is at 1 because I have an amplitude of 1. So this would be my graph for y equals sine of theta. I'm going to do it in a dotted line because it's not my final answer. So to graph this function here, I'm going to find anywhere that my graph crosses the theta axis, and I'm going to put a vertical asymptote. Oops, so 1 over. All right, so there's that. And then anywhere that there's a maximum, I put a point, and I'm going to draw a U shape. It's not a true parabola, but it kind of looks like one. And then I'm going to draw that and that. And that would be my y equals cosecant. However, I have this minus 1 outside. So my final step, so I did all of that in green. And I'm going to do my final step in light blue, is to translate everything down 1 unit. So I'm going to move this down 1, this down 1. And really, my asymptote stayed the same because I didn't translate it left or right at all. So my true graph would look like this. I can do that one a little bit better. Still not great. All right, but that would be the translated function. One more. All right, so sketch the graph of y equals 3 secant of theta. So my first step will be to graph y equals 3, the reciprocal function, which would be cosine of theta. Notice that I brought this 3 down with me. 2, graph y equals 3 secant of theta. And there's no translating on this one, so that's all we have to do. So cosine, I have an amplitude of 3, and I have a period of 2 pi. If you can do this without labeling those at this point, that's okay with me. I'm putting them because I make mistakes, and I need to see that written out for me in my keeping things organized. All right, cosine starts at the maximum. It's a positive, so it starts at the maximum. And so period of 2 pi means it starts and ends at those same points. period of 2 pi means that it goes from 0 to 2 pi. That's how long it takes to complete one cycle. All right, so then my minimum would be halfway between those points. I would cross the theta axis between those, and then I'm going to kind of sketch that curve. All right, so there's that part done, and then my next part is to use a different color and graph the secant. So anywhere that it crosses the theta axis, I put an asymptote. And then anywhere there's a maximum, it becomes a U opening up. I don't really need to graph this side technically. I could just actually leave it like that. That would be okay. It's actually better because we're graphing from 0 to 2 pi. So there's that U. So then this one would go like this and end right there. I've graphed from 0 to 2 pi, and that would be my final answer. So you don't have to show the table. If the table for some reason just makes more sense to you and you want to make a table of values, you can absolutely do that. But I think that this method is going to go a lot faster. I wanted to show you the table method in that first video so that you had a frame of reference for where we're getting these values, and so that you could see this. Basically, what this means is that, notice for the secant value that it starts here and increases, it starts down here and decreases. That means that there's no value of theta that we can plug in to get anything between 3 and -3. So my range would be only values that are greater than 3 or less than -3. This is the opposite to the range of the cosine function. The cosine function can only have values between -3 and 3. So that's another way that we can see how it is a reciprocal of each other and how they are opposites. Head on over to Google Classroom and you can check out your assignment. Let me know if you have any questions.